You take a breath 20,000 times every single day, automatically pulling in the oxygen your cells require to function. To survive, you must continually pull massive volumes of the chaotic, unstructured outside environment directly into your own body. All of that external air, along with the dust, microbes, and particulate matter suspended in it, is drawn down and pressed tightly against internal biological membranes only a single cell thick. Every single inhalation exposes your most delicate internal tissues to whatever hazards happen to be floating in your immediate environment. Your lungs function as an active, highly vulnerable biological defense mechanism, constantly fighting to extract life-saving oxygen while shielding their own tissues from microscopic destruction. The first phase of this defense happens long before the air reaches your chest, starting at the primary gateways, the nasal passages, and the mouth. In this nasal cross-section, microscopic hairs called cilia and sticky mucus form a biological net, trapping incoming dust. As air continues deeper, surrounding tissues warm and humidify it, conditioning the raw atmosphere for the sensitive environment below. This conditioned air then travels downward into the body through the trachea, a rigid windpipe reinforced with rings of cartilage to keep the airway open. Sending cold, dry, or unfiltered environmental air directly into the deep tissues of the chest would instantly damage the respiratory system. This precise sequence of filtration and conditioning is required to make the air safe for absorption. In this rendering, the trachea splits into two bronchi, multiplying into 30,000 tiny branches called bronchioles. At their extreme endpoints sit 600 million microscopic air sacs, alveoli, tightly wrapped in a dense capillary web. At this microscopic intersection, inhaled fresh oxygen crosses a razor-thin biological membrane directly into red blood cells flowing through capillaries. Simultaneously, the cells expel carbon dioxide waste, pushing it back across the membrane into the alveoli for exhalation. This highly synchronized transfer occurs simultaneously across hundreds of millions of individual sacs every single second you are alive. Because this membrane must be thin enough for gases to pass through instantly, it is highly susceptible to damage. It operates as the strict microscopic interface between the outside atmosphere and your bloodstream. When the sheer volume of inhaled particulate matter overwhelms the upper airway's defenses, that friction directly impacts this delicate system. This cross-section of a bronchiole illustrates the mechanical failure that occurs during an asthma attack. The inner lining of the tubes inflame and narrow, and the passage floods with mucus, creating a physical barricade that stops the flow of oxygen. A separate threat comes from microscopic pollution and smoke. Because these particles are small enough to bypass the nasal cilia entirely, they travel straight into the deep lungs. Once there, these pollutants embed themselves in the alveolar membranes, stripping the sacs of their natural flexibility and drastically reducing their surface area for oxygen absorption. Over time, this cumulative damage to the alveolar interface starves the body of the energy it needs to function, making the simple act of breathing an inefficient and strained process. Despite these vulnerabilities, specific behavioral changes can proactively protect and enhance this biological interface. As seen in this diagram, the diaphragm is a powerful dome-shaped muscle located below the lungs. Intentional deep breathing exercises force this muscle to contract downward, which fully expands the lung volume and prevents air stagnation in the lower airways. Regular cardiovascular exercise forces the respiratory network to adapt under stress, strengthening the supporting muscles and training the body to process oxygen more effectively. Finally, consciously mitigating your exposure to environmental pollutants and ensuring your living spaces are highly ventilated prevents unnecessary microscopic wear on the fragile alveoli. Your lungs operate as a tireless, continuous engine. Extending their lifespan and maintaining your daily energy levels requires actively managing both your internal bodily mechanics and the external air you choose to breathe.